When we first talked about waves, we said that they carry energy. They are a disturbance that carry energy. Let's look at that a little bit. Let's not look at it too close because it would get to be a mess, but let's look at it just a little bit. Here's our axis. Here's our wave. Our wave is moving along at speed v. And to think about the energy being carried by the wave, we want to think about basically a plane that the wave is crossing. Now, the way I've drawn things here, the plane will just be a dotted line. It's kind of like when we thought about the frequency. And we said, you know, how fast is the string deflection moving up and down if we just sit at this point? Another way to think of it is sit at this point and watch the wave go by and see how much energy is crossing that point or that plane or that line per unit time. That's kind of what we're thinking about. So if the wave carries energy, it's carrying it past this plane. So the question is how much? Right? Well, we don't think about the total amount of energy. I mean, that would happen in a certain amount of time. Really, we want the amount of energy per unit time. So what we really want, of course, is the power. Is the energy that the wave carries per unit time in watts. Now, for a lot of waves, there's also going to be an area involved. It might be the energy, the power per unit area. But here we're going to be real general and not worry about the area, because I haven't even told you what kind of wave we're talking about yet, because we're not even going to talk about a certain kind of wave. So the power you get that flows by due to a wave depends completely on what kind of wave it is. Is it a string? Is it sound? Is it light? Is it water waves? What is it? Right? So we're not going to get into all those formulas. I just want to tell you something that's sort of generally true about waves, is that power follows a complicated formula that depends on parameters of the problem, but it's proportional to, that means proportional to, it's not supposed to be that big, it's proportional to usually the amplitude squared. So you might see problems that say this wave is delivering this much power, the amplitude changes. That's what you got to think about. The power of the wave is proportional to the amplitude squared. I'm sure I can find cases where that's not true, but in general, for waves, that's the case. So in terms of power, that's all we're going to think about. For anything else, we'd have to do it for that specific system. But this is the thing that's always true.